If you remember a couple weeks ago now, I explained that our goal for this unit was we were going to start looking at sequences and series, which we just covered. And today we will be moving into linear equations. Remember, our goal with this is to go from linear equations to then quadratic equations and then into functions, which is going to give us a lot more power and information in being able to describe different mathematical relationships. So today, you have a scenario here where we are looking at two different movie rental services, Redbox and Netflix, each with a given price. So make sure that you go ahead and read over this problem very carefully. Problem 1 is asking you to create some sort of equation that models what's happening with Redbox. So Redbox is right here, and the cost is $1.49 per movie. And it's asking you a couple of questions, asking you what the slope is, what the y-intercept is. Problem 2 is asking you about Netflix. So we know that Netflix has a cost of $8.99 per month. Let me go ahead and put that in a different color. $8.99 per month. And the questions involving Netflix, we have two of them right here. Problem 3 is a different scenario where it's asking or giving information about a cable company. It gives 3 different price points for 4 movies, $16, 2 movies, $10, 7 movies, $25. Part A is asking how much each movie costs, basically. Part B is asking what the initial cost of the service would be without having to rent any movies. Part C is then we're going to generalize what is going on with the scenario or come up with an equation that models what is happening here. Part D is where we put everything all together, where we graph the two equations from above that everyone created, and we also graph the equation that we came up with in Part 3. It's asking which service would you choose. That's more of a personal preference. It could be based off of many different things, personal preference points, what you would want. So work with those around you, or if you want to work independently, that is okay as well. You can enter everything into Edulastic. Hopefully, if I set this up correctly, it should be good to go. You should be able to check your answers in comparison to what I had, and you should be able to check it a couple of times just to see if you're on the right track. But talk to the people around you, see if you come up with the same equation, check your answers with mine, and then after this we'll go over some notes. So like I said, we are starting to look at linear equations today. Today we're looking in particular at slope-intercept form, which I believe everyone is probably the most familiar with. So our slope-intercept form is really, really nice because it easily allows us to identify what the slope is, which we normally would call m. And we also have our y-intercept, which again we would normally call b. So we are usually going to be either given 2 points. We can look at a graph to be able to find slope, but there's different ways for us to be able to interpret it just based off of what the problem is given to us. We can also calculate slope by looking at this equation here. So we have this equation, m equals, this is pronounced as delta y over delta x, which we know that, again, the change in y over the change in x. So we have y2 minus y1 over x2 minus x1, where the 2 points that we were given are up above as x1, y1, x2, and y2. So we can be given 2 points. We need to be given 2 points in order to be able to calculate the slope. So what does slope mean? Well, we know that for each additional change in x, so as x varies from one point to the next, that also lets us know that there's an increase or decrease in y by some amount. Again, that is going to change on the context of the problem. We also know that a positive slope means that the graph from left to right is increasing, or a negative slope has a decreasing graph where we go from left to right, the slope would be going down. Let's go ahead and look at this simple example that will allow you to find the slope given 2 points. So the example says, find the slope of the line that passes through the 2 points, -3, 1, and 5, -6. I always like to start off by labeling my points, so I would call -3 x1, 1 as y1, and then 5 as x2, and -6 as x2, y2. Did I have to call it that way? Well, it's just the simplest way that I could have done it. Just make sure that the way that you're labeling is consistent. Keep your x1 and y1 together and your x2, y2 together. Okay. So from above, we know that in order to be able to find the slope of a line, we have this equation here that tells us we have to take the y2 minus y1, x2 minus x1. So let's go ahead and plug in our values that we've labeled up above, and we can substitute them. So I get -6 minus 1 all over 5 minus -3. Go ahead and simplify the top, and -6 minus -1, or minus 1, will give us -7. And 5 minus -3, remember 2 negatives make a positive, so that's 5 plus 3, which gives us 8. So just using our standard formula for slope, we have that the slope, given those 2 points, is -7 over 8. So, like I previously said in our equation, y equals mx plus b, it's really nice that we can just automatically read off what the y-intercept is, but conceptually remember that the y-intercept is the line that crosses the y-axis, or where crosses the y-axis. This happens when our x value is equal to 0. Remember that the y-axis is going vertically, so our x value will be 0 on that line. In this equation, or in our equation of y equals mx plus b, it is the value that is b. Scrolling up above, I did talk about that up here. So we can automatically read off what the y-intercept is, and we can obviously read off what the slope is. That's what's really, really nice about slope-intercept form. Even if we didn't have to particularly know that the y-intercept was 6, we can check it. So, like I said, the y-intercept is when our x value is equal to 0. So I can just straight substitute the value x equals to 0 into this part right here. And after I do that, I get y equals 5 times 0 plus 6, which we know that 5 times 0 is 0, plus 6 will give me 6. So, easy way to check what the y-intercept is, and we can just substitute our x equals 0 value to find what it is too, if we just didn't remember what that was. Lastly, there's 2 special cases that we need to talk to that can be difficult to use the slope formula in, or maybe it gets a little bit confusing to use the slope formula in, but okay, just remember that we have horizontal lines here. Remember horizontal, we can think horizon. So a horizontal line will always have a slope of 0. And we can think about this definition of slope, where the slope is equal to the change in y over the change in x. Well, if I look at my line, my horizontal line over here, there's no change in y. So there's no up or down. The equation of this horizontal line is y equals 3. Y will always equal to 3 on this particular line. Meaning that if I choose any 2 points on this line, doesn't matter where, I can choose this point and this point, there's going to be no change in the y value. So after I subtract them, I'm going to get 0. And we know that 0 divided by anything else is just going to be 0. So the slope of a horizontal line will always be 0. And let's look at the scenario for vertical lines. So let's go back to our definition of what slope is. Again, it is the change in y over the change in x? Well, if I look at any 2 points on this line here, remember, a vertical line goes up and down, and the equation for a vertical line would be x equals something. I just threw in x equals 4 here just to have a number here. But if I look at this line, these 2 points on the same line, and there's no left to right movement off of that line, so the x values do not change. So when I subtract the same exact x value, it will be 0. But remember, anytime I am dividing by 0, or I can actually divide by 0, we call that an undefined slope because we cannot divide by 0. So remember, a vertical line will always have an undefined slope because when I subtract those 2 points, or the x values on those 2 points, they will be the same, giving me 0, and we cannot divide by 0. So just remember again, one last time, horizontal lines will always have a 0 slope, and vertical lines will always have an undefined slope. Just a reminder that you do need to make sure that you're writing in the notes. I don't think that they give us enough space in the quick notes, so again, make sure you're writing this in your notebook, name, date, period, and label it lesson 1.5, linear relationships. Lastly, all that you have left to do is you have to check your understanding right here. It's giving you a couple of questions, 5 questions, just going over the material that we just went over. So go ahead and input your answers into pair assessment. You should have a box for each of these questions, and that should be the rest of class. So again, just make sure you read over these problems very carefully. We went over everything that we needed to in the notes. Make sure your notes are in your notebook, and you have your homework. So you have lesson 1.5 homework. That should look like this. You should have a paper copy, but remember, it's also on pair assessment. Whenever I'm able to set up you guys having to send a photo of your work, I will get that out to you. If you ever need anything, just send me a message on Remind. I will try to get back to you as soon as I can. But you have your homework to complete as well. That will be due next Tuesday at midnight. Again, reach out to me if you ever need anything. Hope this goes well.